see you. Thanks for joining. We really appreciate you taking the time to attend this webinar. So we thought it would be a good opportunity to kind of talk to you a bit about eSkimming, e-commerce protection, the PCI implications of that. So, what are the PCI requirements that are new in version 4? Share a little bit of insight about that with you. And then, we've collaborated with our partners at Source Defense to talk a little bit about their solution to address that and kind of show you what some of the capabilities are of tool sets that are out there to support you in this and the offering from Source Defense. So we've got some folks from Source Defense here that are going to chat about that. I lost my presentation window. There it is. My name is Ian McMillan. So I'm a senior manager in the digital compliance practice here at MNP. And I'm a PCI QSA. So I'm formerly a software developer. My background is technical. A turned security professional. Got a couple of different security certifications, designations. As I mentioned, one of them is Qualified Security Assessor from PCI. Like I said, my background is development, and user interface, and user experience. So these are the kinds of things that I bring to my security career as a security professional and consultant. I previously co-founded a SaaS company that develops a security awareness tool. And that's largely where a lot of my experience with development and security and integrating with client environments kind of comes together. So I've got lots of experience understanding client environments, both like bleeding edge and legacy, the web aspects of that, the web application aspects of that. And currently in my role as a senior manager in our digital compliance practice, I'm a QSA for organizations, small and large, household brands, provincial governments, municipal governments, higher ed, across Canada, as both an assessor and a consultant. So I support my clients in helping them, become PCI compliant and answering their questions and being that sort of voice of reason for them and understanding, the standard that is the PCI DSS. And I also work as an assessor. So I perform reports on compliance and assessments for reports on compliance and assessments for self-assessment questionnaires with my clients as well. So just talking a little bit about, some of the technical aspects of this. So, e-commerce environments and e-skimming is something that's really come kind of to the forefront in version 4 for PCI, like particularly for organizations that have smaller e-commerce environments or smaller payment environments. So, we have a lot of clients in our compliance practice here at MNP that are outsourcing their payments to a third-party service provider like Stripe or Moneris Checkout, or they have that embedded iframe or that redirect. They have a low number of transactions, so they're completing a self-assessment questionnaire A or an SAQ-A. And then we have, of course, clients that have that higher number of transactions where they're in, the report on compliance, the ROC territory, or they're a service provider, and they are an e-commerce service provider. The theme, kind of the main thing I want to emphasize here that is important to note is that JavaScript that essentially manipulates the page and allows that interactivity with your application or your payment page is loaded and executed client side. So that means it's actually executing within that consumer's browser and is therefore outside the purview of typical security monitoring tools. So the idea is, your web server is sending that payment page out to that client. It's landing on that consumer's computer, that user's computer, and being executed in their browser. And the JavaScript and all the things it's going to do to manipulate that page, whether it's plugins like date selectors, for example, or interface elements to make the page interesting, or it's a script from your payment service provider to be able to generate the form to collect payment information, or whatever the JavaScript is. It doesn't actually run until it lands in that consumer's browser. So it's happening all on that client side. E-skimming attacks are essentially attacks that are occurring in that environment on the consumer's browser, within the consumer's browser on their machine. So that page has already left your environment, it's in their browser. What we typically see is sort of this 5-step process for e-skimming attacks. So just have a couple different names. E-skimming is one, mage cart attacks is another. We have a lot of examples of these in Canada and actually in the US as well. So you can certainly find examples of this. But the idea is that an attacker is first going to gain access to the e-commerce website or to the supply chain that's supporting that, the infrastructure that's supporting that page. So there's a whole bunch of different ways that this can happen. Google Tag Manager is an example of one where it's a marketing tool where Google Tag Manager actually inserts snippets of JavaScript into the page. And so, you might have a JavaScript compromise in Google Tag Manager that injects itself into the page and is now able to skim credit card information. It could be a plugin that's been manipulated. So, someone's looking for something like a date picker or some kind of interface element to make the page more dynamic. And they pull that down and plug it in. It never gets maintained, and now it's been compromised and it's injecting malicious JavaScript. So there's all different kinds of ways that can happen. In some cases, it can be stolen admin credentials, exploitation of unpatched devices. These are all things that we look at when we do your PCI assessment, or content delivered through a content delivery network like a CDN. But the idea is ultimately there's some way that a malicious actor is able to inject JavaScript on that page to be executed, again, client side in the consumer's browser, and then manipulate the page to do things down the line. So the things down the line they do is once they've injected that malicious code, so it can be like a JavaScript skimmer, it's designed to look legitimate, makes it really hard to detect. So, in some examples, if you have a look at if you do some research in some of the case studies out there, a lot of times the JavaScript is obfuscated. So it makes it difficult to detect through any means of, vulnerability scanning, for example. It can be really difficult to, determine that that's in there. Once it's in there and actually running in that consumer's browser, it's going to perform data harvesting, which is obviously the goal, right? So it will quietly copy out credit card information, CVV, so your PAN, CVV, expiry date, any of the information that the user's entering. It can be done with logging. It can be done with redirection. So in some cases, a JavaScript might actually redirect the user to a payment page that looks legitimate, or they're just harvesting the credentials or harvesting the cardholder information, as it's being processed by the payment service provider. Like there's all different kinds of ways that they can sort of inject themselves and skim off that information. Of course, once they are able to actually harvest that data, they exfiltrate it out. So this is usually out to an attacker-controlled server using obfuscation to disguise as legitimate traffic. In some cases, this can be using manipulated HTTP headers. So the idea is when they actually exfiltrate that data, any of the logging that you're seeing would actually look like legitimate, search engine optimization stuff, like from Google, or maybe content being loaded or received from a CDN or a response back from your payment service provider. So it's spoofed to look like legitimate traffic. And a lot of times they'll use compromised infrastructure. So they'll steal somebody else's infrastructure and use it to harvest, credit card information from your website. And again, it's to avoid detection. And then finally, once they've done that, is the monetization piece. So they'll actually sell that card information on the dark web, or they'll use it for their own fraudulent purchases and skim a bunch of money off cards. The gist of sort of all of this is demonstrated in this XKCD comic, which is one of my favorites. So, as a developer, I can tell you that using JavaScript plugins or JavaScript libraries to do different things on my page is like standard practice as a developer, right? So we bring in things like Bootstrap, which is Twitter's former framework for mobile responsive web design, or jQuery, or like any one of these libraries or plugins to make our page more dynamic and interactive. And the idea is, it's important to vet that stuff to see where that's coming from, because everything sort of relies on these libraries that we have embedded in our pages. So there's two major requirements that pertain to this in the PCI DSS as a version 4. The first one is requirement 643. So essentially, the gist of this is scripts that are loaded and executed in the payment page can have their functionality altered without the entity's knowledge, and potentially even load in other external scripts. And so the requirement here is that all payment page scripts that are loaded in the page, this is all of your JavaScript, there's a method implemented to determine that each of them is authorized. So that means that if an additional script gets injected into the page, that's not authorized, it's not permitted to run. There's a method implemented to assure the integrity of each script. So validating that the script that's loading is the script that was sent from the server, that it hasn't been manipulated in some way, and that is not something that's changed within that script that could potentially be malicious or harmful. And then finally, an inventory of all scripts is maintained with written business or technical justification as to why it's necessary. So that way you don't have something being injected into the page that you're unaware of and that you aren't expecting that could potentially be harmful. Our testing procedures for this usually as assessors, we're going to look at your inventory, we're going to examine your policies to expect you to sort of demonstrate how you justify these scripts and how you maintain that inventory of scripts, and any of the things that are in there are supposed to be there. And then interview obviously responsible personnel to understand that how you're maintaining this and how you're actually validating that the integrity of the scripts is maintained and that each of the scripts in that page is authorized. So really quick example here, I mentioned Google Tag Manager earlier. So it's a marketing tool, and Google Tag Manager essentially allows someone to go in the Google marketing dashboard on the Google side, paste in JavaScript for search engine optimization purposes for things like tracking Google Analytics and things. And that will actually inject itself into your pages on your website when Google Tag Manager loads. So the idea is if someone compromised the Google account, they could essentially inject whatever they want into your web page without actually having your development team involved. So that's an example where understanding everything that's being injected in there is really important. The second requirement is requirement 11.6.1, and it focuses largely on the content of your scripts and the HTTP headers that are being sent and received between the consumer's browser and your web server. So a change in tamper detection mechanism is deployed to alert personnel to unauthorized modifications to security impacting HTTP headers. So this would include things like content security policy or CSP, and that script contents of payment pages are also covered. So the idea is, we're validating the integrity, of course, of when something is received, but if after that JavaScript has loaded, there is manipulation done to it, that there is an alerting mechanism that will alert personnel within your organization that that sort of stuff has happened. And again, that's happening with the HTTP headers as well. So if you defined a content security policy in your HTTP headers that says only scripts from certain places or only specific scripts are allowed to load, if those headers are manipulated in some way, there should be an alerting mechanism to ensure that you're aware of that. And then the mechanism that does this needs to function or perform at least weekly, or you define a period or frequency based on your targeted risk analysis as defined in requirement 12.3.1. And as a quick recap, 12.3.1 is the requirement that defines that you have a methodology to perform a targeted risk analysis. With this one, again, our testing procedure, we're going to look at how this is implemented. We're going to want to examine configuration settings to understand how you're doing this. So how you implement a solution for this, like such as source defense, for example. We're going to validate that it's happening at least weekly or based on the targeted risk analysis that you've conducted. And then if it's functioning, we want to make sure that it's functioning properly at that frequency that you've defined for that targeted risk analysis. So that's sort of the two requirements. There is a little bit of a quirk to this. So originally, when version 4 came out, the PCI Council included 6.4.3 and 11.6.1 into the SAQA and then walked that back. So in January, they made an announcement that they were actually going to remove 6.4.3 and 11.6.1 from the SAQA, but they did introduce this new eligibility criteria. And this has caused a little bit of noise in the QSA world because we've been trying to figure out how to interpret this. And essentially, the new eligibility criteria for the SAQA is highlighted here on the right. So the merchant has confirmed that their site is not susceptible to attacks from scripts that could affect the merchant's e-commerce systems. So if you have an e-commerce environment and you're doing your validation using based on an SAQA, so you're below that threshold of transactions where you would be required to do a ROC, you have to demonstrate this eligibility criteria as well. And as a QSA team here at MNP, we've gotten together and put our heads together and decided how we want to do this. And we've decided that we would accept demonstrating 6.4.3 and 11.6.1 as sufficient to meet this eligibility criteria. So that means if you're looking to figure out what you need to do in order to be compliant in your SAQA to this eligibility criteria, implementing the two requirements that I just showed you is how you can do that. And as I mentioned, I'm going to flip it over to Matt from Source Defense here in a moment. He's going to give you a demo of Source Defense and how they do that, how their solution achieves that. But essentially, even though those two requirements are not in the SAQA, from a QSA perspective, we would accept those if you're looking for how you can implement this to meet that requirement. So that's kind of just the preamble I have related to the PCI requirements. I'm going to flip it over to Matt now. He's going to give you a quick introduction and do a demo for source defense. Go ahead, Matt.
Thank you, Ian. I appreciate it. Thanks to everybody for joining today. My name is Matt McGurk. I'm our head of field engineering here at Source Defense. So that means anytime we talk about our tech in public or do evaluations or et cetera, that runs through my office. I've been here for a very long time. I've been with Source Defense for coming up on 7 years now. And I also have a technical background in web application development. And I've been talking almost exclusively about PCI requirements 643 and 1161 for 2 years or so now. So I'm happy to be able to contribute to the conversation. What I'm going to do for you guys here over the next few minutes is give you kind of a demonstration of the problem. So I want to flesh out that idea of eSkimming attack and what it means for you in a practical sense, because I find, for me anyway, it can be easier to have some images to go along with the concepts. Second thing I'm going to do is show you what Source Defense does and how we approach this problem and solve it for our customers. And I would note that if anyone has any questions, Ian and I will be taking those towards the end of the call. So feel free to throw them in the Q&A thing here in Zoom, and we'll handle those as they come up. If I see one pop in and it seems relevant to whatever I'm blabbing about at that moment, I will take it as it comes up. But no real promises there, unfortunately. So what I've done on my screen here is just bring up a web browser. I'm showing you the New York Times for no particular reason. It's a public website that I can show you here on the screen. And what I wanted to point out was just kind of like the problem statement as we outlined. So we're imagining that this is a payment page behind me. But if it were, what we would need to do to make this payment page compliant under 643 and 1161 would be to inventory, justify, and secure all of the JavaScript that's present here. So at the bottom of my screen, what I'm showing you is the JavaScript that's loaded into this web browser when I access this page. So the browser was instructed by the web page, hey, I need all these different parts to make the page go and be what it is. And the browser dutifully retrieved all this stuff and then executed it. So like the key idea here is that this code, no matter where it came from or what it is supposed to do, has literally unfettered access to the web page and what it looks like and the data within the web page and so on and so forth. So JavaScript by default has no like native security model in the browser. It's got some relatively lightweight controls, content security policy, and sub-resource integrity. You may have seen if you read the standard in depth, but they don't really do anything to like prevent the sort of actions that cause the attack that we're discussing today. The other thing I would note, as Ian described, a lot of this code is, in this case, what I would call first-party code, meaning it's written and developed and maintained by the hosting organization, by the New York Times or by one of your organizations. So that's your own code, so to speak. There's also going to be a huge amount of third-party code loaded into the web browser. This is all stuff that's integrated into the web page because of the design of the web. I mean, like, the New York Times has chosen to have these things here, at least in part, because it helps their business some way. It helps sell ads, it helps record user behavior to optimize the site, et cetera, et cetera. So they've installed this stuff, and now it has unfettered access to the page. And then one more note here is that this code very frequently loads other code dynamically. So when I said, the Times has chosen to put this here, it's true, but they kind of also let those things that they install whatever they want on the fly. So that's the nature of the problem. How are you going to inventory all this stuff, secure it, assure the integrity of it, and so on and so forth, especially considering that the list is pretty dynamic. Like it can change based on region and user behavior and so on and so forth. So that's where we start with this. So what I want to show you is a simulation of attack against this web page. And what we're going to kind of do, if you recall that 1, 2, 3, 4 kind of step-by-step that Ian showed a few moments ago, we're kind of going to assume that step 1 there has occurred. Like some part of this infrastructure was breached, one of those vendors was breached who's supplying some of that code. That's the thought experiment. Of course, I haven't actually done anything to the New York Times here. I just am simulating this by manipulating my network in the background. But that's the assumption that some kind of compromise has happened and now malicious code is running in my browser. So when I navigate to this login part of the New York Times, let me just split my screen up here. You can see on the left-hand side, I've got the normal New York Times login process. On the right-hand side of the screen, though, I've got this black and green terminal window. And this is the attack that is kind of sprung into action from that available loophole in JavaScript and is now doing stuff and waiting to do stuff in my browser. And so, of course, in reality, these attacks don't have a big black and green terminal thing. That's simply for the sake of illustration, and so you can see what's happening. So what I'm going to do here is begin my process over in visitor land to log into my Times account. As you can see here, the attack has no issue whatsoever skimming off the information I type into a form. It's a very basic cornerstone of any kind of eSkimming attack. The second thing, though, that this script is going to do, maybe a little bit more interestingly, is change what the web page does on the fly to steal more information. So if you are a very close scholar of this kind of attack, DSS has started to call this a double entry attack. So if eSkimming is like a straight up silent taking data from the web page kind of attack, double entry is the same problem, but it involves the injection of another form into the page or some other kind of manipulation of the page to convince the visitor to enter data when they might not otherwise. And so I'm kind of belaboring this point because you may have thought, we for years were operating on the assumption that using an iframe provided by a payment service provider would sew up this problem. You wouldn't, need to do anything else because of the nature of iframes, and you couldn't get into an iframe if you're an attacker, so on and so forth. This kind of attack that you're seeing here blows that out of the water, because what the attacker can do is simply put their own form on the page. They can present it as a legitimate part of the checkout process. And then, of course, the transaction would fail because this is a fake form. But then they can present the original form. They can remove this, replace it with the original form, and let the visitor complete their transaction. So that's two entries of the card number. Therefore, the attacker gets it and the visitor can complete their deal. So a double entry attack is one of the reasons why DSS is being so particular about enforcing these. So here in my demonstration, what we're going to do is click proceed to my account. That's just going to forward us to an error message and then to customer support, because in this case, for a demonstration, I don't want to interact with the New York Times web app in any real way. But in reality, like I mentioned about the double entry stuff, there's no reason that the attacker can't just let me continue to my account. In this case, complete my transaction, whatever. And as a result, you get two different things. You get a lot of different things, but this is invisible to the visitor. Like if I didn't have this thing over here on the right, there'd be no way to know that anything really went wrong with my interaction with the Times. The second thing is that it's invisible to the New York Times. I've been doing some version of this exact same demo for like 6 years now. And they're still cool with it. So what I'm trying to say is this didn't happen on their servers or like inside their firewall. There's no log of this somewhere. So those two things put together, invisible to the visitor, invisible to the hosting organization, those two things make this really difficult to solve for and detect and maintain and et cetera. So that's all by way of saying these are why we have to do things in DSS 4.0 to solve for eSkimming and otherwise client-side security matters. And by the way, just as an aside, as I pivot over here to what Source Defense does, you may also hear the term client-side security in this space. We certainly use it here at Source Defense. What that means is web application client-side security. So the web browser being a client to a web application on a server. Anyway, I didn't want to hit that too heavily, but I never like to use a term without defining it. So what I've done, as I was rambling there, is move over to Source Defense and what we do. So like I said, we've been in this space for a very long time. We, in my opinion, kind of created the category. We have a whole suite of tools and technology, but the whole company overall is dedicated to exclusively solving this one problem. So we're not like a bolt on to some other WAF product or this is our raison d'etre, so to speak. What you're seeing on your screen right now is one part of our platform that is dedicated exclusively to helping our customers solve for DSS 643 and 1161. So by solve for, I mean one, complete the tasks that you would need to in order to be compliant, and then two, to provide evidence that you've done those things so that you can complete your assessment or your ROC or however else you need to satisfy that kind of evidence production. Usually, and I won't get too technical here, but folks are curious about like, how does this get deployed? How does this get added to a web application? We are added as JavaScript ourselves so that we can observe all that behavior that was otherwise invisible, like I mentioned. To boil all of the technicals out of this, I would give these lines of text to our customer. Their developers would copy and paste this into the right part of their web app, and then they're done. There is no further network configuration or appliance installation or anything like that. The rest of everything you're seeing in these dashboards just happens automatically after that code's installed. And that allows us to do things like, and as you might recall from before, we have a variety of different, let me pivot over to a slightly different dashboard I like a little more. Once we're installed and in place, we can do things like automatically inventory all of the JavaScript on a website. So down here, there's at least one way of viewing that in the platform. Basically, a visualization. So if you contrast this with what I showed you before, that file list, being able to visualize something like this can make your life significantly easier after we've automatically collected all this stuff and categorized and classified it for you, especially in that supply chain case. So I mentioned before, this type of code likes to add other code on the fly. And you can see that case pretty cleanly illustrated in the middle here, where if I have to explain to someone, why is something called the Zoom info service on a payment page? Well, I can tell them in this case, it's there because of the YouTube image preview script, which is there in turn because of the YouTube player, which is in turn there because of Matomo, and so on and so forth. So that little story you can tell about where did this script come from becomes dramatically easier if you're using a tool to do that rather than trying to do that analysis by hand. The second thing that we do is observe script behavior. So like I said before, I called out something called content security policy. That's one way to try to approach this problem. It's different than us. We do a totally different thing. With CSP, you're kind of like, can code load from this domain or not? It's a very black and white thing. For us, we're observing about 100 different signals out of the browser as the visitor's going through their thing on the website. We turn those 100 or so signals into about 10 different behaviors, like you're seeing on the right. And then in this widget here, you can see at a glance everything that the scripts are doing in aggregate, and what's transferring data out of the browser, what's loading code from a suspicious location. If that's happening, what scripts are interacting with card data, so on and so forth. So we take this behavioral approach rather than ask folks to figure out what domain names, what scripts belong to, and so on and so forth. We further combine those behaviors into events. And then that's how we kind of communicate stuff out of our platform, meaning you can receive email alerts or alerts in your SIM or other system based on what you're seeing, what we're seeing on your sites, and then have your team work with it that way so you don't have to live in this dashboard if you don't want to. Zooming in just a little bit more and into a particular script, let's use Google Analytics. You can see here the detail about this particular script, imagining it's on a payment page. The other thing I would need to do, the other two things I would need to do, so we talked about inventorying scripts, which we do automatically. We talked a little bit about behaviors. I need to make sure that these scripts are authorized and justified to be here. And then I have a way to assure the integrity of these scripts moving forward. And so you can see here, we handle justifications in our system. Basically, we become the system of record for these things. We can even help you automatically generate these if you want. We can't read your mind, so you may need to add details about like your intent, but we'll get you 90% of the way there. And then this becomes an auditable, justifiable, long-term place to store these rather than a spreadsheet or et cetera. The second thing I wanted to point out on the screen is behaviors and basically behavior acknowledgement. So I can see more information about these scripts and what they're doing and what kind of data they're interacting with. And the other thing I can do is train the system, as I've already done. You can see these little check marks here. I've trained the system about what is and is not acceptable for this Google Analytics script to do. Meaning that in the future, if Google Analytics keeps doing these things that I've determined are fine for a marketing script to do on my page, then it'll keep running. Source Defense will observe it, but won't fire off any alerts, and it'll all be hunky-dory. If the script starts doing something new and deviates from that normal baseline, then Source Defense will fire off the appropriate alert and let you know that's going on, so you can hop back in here and review that and basically reassure the integrity of it. Make sure that script still has the still is doing what you want it to be doing and is acting appropriately for your use case. The other thing I wanted to point out while we're here is something we call Source Defense Protect. That's our ability to actively control what code does as it interacts as it runs inside of a web page. So I wanted to be clear, we're not just like a reporting and recording and analysis tool, we're an active security control as well. So if I want to, for instance, I can choose to redact any sensitive information from an analytics tool like Google Analytics. So basically we would prevent this script from accessing sensitive data if it tried to. This isn't the same as outright blocking the script or, hey, this signature doesn't match, so we turned off this part of the web app or something like that. We're filtering behavior, and we're doing that all the time. And as a result, we put you in a pretty strong spot, a very strong spot, both from a security standpoint, because you don't need to be reactive to alerts. We're just going to handle that for you, basically. And then from a second standpoint, we're talking very closely about DSS today, but consider this in other privacy or compliance frameworks or other stuff. You're in a much stronger spot if you can say, yeah, our analytics tools can never touch passwords or card numbers or citizen ID numbers or such, rather than a trickier kind of business associate or other agreement, et cetera, et cetera. So I'm going to bring it back home here to the DSS dashboard for the sake of landing somewhere. We put all those different tasks I described into a couple different workflows. So what I mean by that is if I'm a user of the system, maybe I receive an alert saying that there's a new script that requires justification or that there's a new behavior that requires acknowledgement. The system then guides me through, okay, here's the 5 scripts that still require justification. I generate my justification, click authorize and justify, and then that task is complete. And then at the end of the year, when I need to furnish evidence of that, we've got you covered there too to handle any reporting. Basically, this will kick out a zip archive that should satisfy, or at least, I can't speak for the QSAs at MNP directly, but I would believe this will probably satisfy whatever evidence collection they're interested in. We did train those and kind of put them together with the advice of assessors in general. One more note, if you do have a relatively complex use case, so a lot of times I'm talking to folks who have multiple brands or many payment pages or international presence. We have some pretty elegant ways, in my opinion, of handling multiple sites and kind of scripts in aggregate. So if I have Google Analytics installed across a half dozen different web properties, and I need to justify it kind of in one fell swoop, I can go through here, see all the sites that, in this case, Google Tag Manager is installed on, tick them off, mass justify them here, and then that's complete, or mass acknowledge behaviors, so on and so forth. And then I'm done with that script for the entirety of my estate. And one more note. I am pretty proud of our in-product tutorials. So it's not like the flashiest thing in the world, but especially this first year, as folks are just getting this under their purview, and we're all kind of learning together how to satisfy these requirements. We will walk you through your own specific data and train more or less on your behalf. I think someone with an okay, like maybe 15-minute introduction to what's going on here and why are we all talking about this, can then bootstrap themselves up into actually doing the day-to-day tasks and handling the compliance workload without anybody on this call having to become a trainer in source defense. So I think I've been talking at length. I will pause here. Like I said, we have a couple questions that have filtered in. There's some specific compliance stuff. There's some other stuff, but I'll stop talking and we'll open it up to the floor and see where we want to go from here.
We've got a couple of questions in the Q&A, Matt, so maybe I'll just jump on those. So one question we have is if we can confirm if 643 and 1161 still apply if a payment page redirects using a server-side redirection, so like an HTTP 302 with a script being involved. So I've actually got the guidance document from the council open, and I'm just going to share my screen and show you what that says. So here it is. Great, so you should be able to see my screen here. So this is the guidance from the council on redirection mechanisms. So what it mentions is redirection involves transferring consumers to a separate merchant website. Redirection mechanisms can be implemented via server-side configuration settings. So that's that redirection, the HTTP 300, HTML tags or JavaScript, where scripts are used as part of the redirection mechanism. PCI DSS requirements 643 and 1161 will apply to those scripts. So based on the guidance document here, my take is, or our take as a team is, a server-side mechanism wouldn't be in scope for 643 and 1161. Now, having said that, your implementation of that is very important. So if you have a link on the page that triggers a callback to the server, which then fires that redirection, we may say that that redirection is dependent on a front end, a client side interaction. Whereas, for example, if you have some kind of submission that goes back to the server side, which then triggers a redirection to the payment page that's not influenced by a link that can be manipulated in the DOM on the client side page, then we may indicate that that's not in scope, right? So have a conversation with your QSA about it. Out of the gate, though, I would say it's probably not going to be in scope for 643 and 1161, but just check with your assessor just to make sure. But good question. Another question we have is the requirements for 643 and 1161. What's the scope? Is it only the scripts that are loaded on the payment page, or is it your whole website? So the scope for those requirements is the payment page itself. So if you have an iframe or you have a JavaScript that's generating a form, that would be in scope. And then if you're using a redirect, the page that's redirecting to the payment service provider's hosted payment page would be in scope. So again, page that houses your form or your iframe, or the page that's triggering that parent page that's triggering that redirect over to the payment service provider. And then a follow-up question to that is, does this apply to both the redirect and fully outsourced e-commerce implementation? So yes, it does. So the definition for fully outsourced is a tricky one. So if you're using something like Shopify, where your entire experience is within a Shopify store, then no, 643 and 1161 doesn't apply. The redirect is, I have a purchasing environment on my website where I build a cart or I redirect to a donation or something to that effect. And the redirection lands you on a form of a hosted service provider payment page that has the form for you to enter your cardholder information. So that's sort of what we define as the redirect. That's still technically fully outsourced. What I would suggest is your third-party service provider, your payment service provider, will have a responsibilities matrix or a RACI document, and you have to look at what requirements they indicate that they're responsible for, and then what requirements you're responsible for. So for example, if you have an outsourced third-party service provider for payment, check the requirements matrix, see if they indicate that they're responsible or you're responsible for 643 and 1161. If we're using a single page application like React, my understanding is that the entire React application is in scope, right? Yeah, good question. So single page application architecture is essentially one page that loads content dynamically in and out. So yes, for a React-based environment, yeah, there it is. Yeah, so single page applications doesn't reload the entire page. And so you would have to, your entire website essentially would be in scope in that case. Yeah, good question on the single page app. Looks like a couple of the questions that were asked were actually able to be answered in the information document. So in the guidance document, so we can actually share that guidance document from the council with you because it has some pretty good information there related to page structure, scope, redirects, all that sort of stuff.
I want to call it the first part of that anonymous question was they got to the outsourced e-commerce, but they were asking if something's been removed from the SAQA, if 643 and 1161 have been removed from the SAQA, why are we still expected to implement controls? And I mean, I'll key it off. What the language changed to is one must make sure that their page is not, or their site actually is not susceptible to script-based attacks. And somebody's got to own that in the responsibility matrix. That's my understanding. And would that be yours as well?
Yeah, so the way it kind of works, and I apologize, I missed that first part of that question. So the thing is, and we discussed this as a QSA team, so in order to be eligible for the SAQA, you have to demonstrate that eligibility criteria, meaning you have to show that your website is not susceptible to these kinds of attacks. So what we said was, okay, so let's say someone is not doing that. They haven't implemented a solution like source defense. Are they eligible for the SAQA? Well, technically no. And so that means now that they have to move to a different SAQ, and all the other SAQs related to e-commerce have the requirements of 643 and 1161. So it's kind of circular in that way. So you do have to demonstrate that you're doing this in some capacity to be eligible for the SAQA. And a great way to do that, if you want some guidance on how to do that, I mean, 643 and 1161 are the best way to accomplish that. So that's why we would accept that as to meet that eligibility criteria. That was a good question. Any other questions? Questions about source defense for Matt? Questions about PCI for me? We got a question about scripts served from the CDN here. So 100% of our scripts are served from the CDN, but script names change every build. We have Webpack, so our scripts include all of our code, and every single dependency are all mixed into the files we serve up. What are the implications for this for script inventory? Yeah, that's a really great question. So I think there's two parts to this. There's PCI side and source defense side. So for the PCI perspective, the implementation doesn't really influence the requirements. If you have a payment page and you're collecting card information in an iframe or in a redirect or using JavaScript, you have to be able to demonstrate those requirements. And so even if it's challenging, like even if the names of your scripts are changing all the time, you still need to be able to demonstrate that. Matt, did you want to comment on that in terms of like the capability from source defense and how to address that one?
Yeah, I'll start with, you may have it a little bit easier than you think you do. If it's a Webpack, there's every chance that that's going to end up as at least one or a small subset of files once it hits the browser. And my understanding of this requirement is that we're talking about the scripts as they exist in the client at runtime, rather than a complete decomposition of every thing that comes up and gets compiled into that Webpack and dehydrated. So in that sense, you might be in a case where you're saying like, the inventory is this file. We slammed it all down into one Webpack and it gets rehydrated. What we really care about in DSS 643 and 1161 is that network tab in Google Chrome or Firefox or et cetera, and what files are there and can you justify them? So you might be in a little bit easier case unless you've got some like really interesting thousands of JavaScript files. If you did, we help with that. So we grab the inventory every single time a page loads. So even if you're rebuilding everything and it's got unique hashes at the end of it, like you said, for cache busting or whatever, we're going to grab it no matter when the release happens and the code changes. And then we can give you options to basically justify the entire front end, like as one unit, or to group things by pattern. So, hey, it's front end -hash.js. We'll give you ways to say, just show me whenever anything matches this pattern, and then we'll do it that way. So yeah, we see that use case a lot, especially if you've got like Rails as a framework or et cetera. And we're, I think, very good at handling it as well. So interesting question. And yeah, especially with the single page application stuff, we're hearing it more often.
There's a follow-up to that one too, Matt. So, and I think it's for me. So the business justification would be, this is our website and all its functionality. Is that sufficient? So I would say, as a QSA, what I would expect is specifically, this is the script for our date picker. This is the script for our Google Analytics. This is the script for X functionality, right? We had this script on here because we need it. Wouldn't necessarily be sufficient. We need to understand the business justification for actually putting it on the page. And the intention there is that the merchant is being deliberate in understanding what they've put on their page and why, to prevent something from just sort of ending up in there. So yeah, I see you send another follow-up. So I think what might be good is, why don't you reach out to us? Let's have a look at how we can help you, figure out the best way to do that. I understand like sounds like using a single page app, using Webpack for compiling your front end. So yeah, let's have a look at it and look a little bit more specifically at your implementation. But yeah, these are all really, really good questions. Yeah. Looks like there's a question there for the pricing model, Matt.
Sure. We'd want to get into specifics with you, of course, but the basic idea is, how many payment pages do you have and how much traffic goes through those? We're putting code on those pages, so we have to know some of that to figure out our costs. But that's the basic idea. What do you need to protect, and how much does it need protection, I guess?
Okay, great. Someone asked if the PCI requirements are applicable for application scripts on the payment page or only scripts rendering the iframe. So I use the iframe example because we see that a lot. Essentially, even if you're a service provider or you're doing a ROC, let's say you're storing cardholder information, right? And you have a homegrown form. You're not actually using an iframe. Yes, 643 and 1161 apply to that page and any of the scripts on that page. So the general rule of thumb would be, if you have a page in which a user is entering cardholder data onto that page, or clicking a link that takes them to a page where they would enter cardholder data as a redirect, you are required to demonstrate 643 and 1161 on that page. So the hosting page itself where cardholder data is captured, meaning like where the iframe is, where your form is, or where the JavaScript renders a form, or the parent page that redirects you off to your third-party service provider if you have one? Good question. Sorry, Matt, we can't hear you.
That's right. I've been talking a lot. And I think to follow on, that applies to every script on the page, right? Not just the one that's involved in rendering a payment form.
That's right. Yep. So I have an iframe and I have a, Moneris checkout or a Stripe in there. But I have a date picker, or I have a, some kind of JavaScript plugin of some kind, Google Analytics, what have you. Those have to be included in your inventory, and the integrity of those scripts have to be validated. Looks like there's a question about scripts within the iframe. So yeah, great question. So the scope of your requirements here, the scope of what you have to demonstrate compliance to, does not include the content within the iframe. So that's hosted by your payment service provider. So if you're loading Moneris checkout or Stripe or whatever TD Bambora, whatever you're using within that iframe, you don't have any control over that page. And that's actually on the requirement. It's a requirement of the service provider to be compliant for that page. It's the page that actually houses that iframe that you're responsible for. So it's any of the scripts that are loaded on that page, but not any scripts that are within that iframe on that page that's rendering to collect the payment. It's a good question.
Yeah, just to follow on that real quick, we would exclude that iframe from our reporting. If you are a payment service provider and you're watching today, we can help with the stuff in your page in the payment form, but a merchant or somebody else embedding a payment form from a payment service provider, we will show you only the stuff you have to care about in your scope. You don't have to manage anything you don't have responsibility over.
Looks like there's a question here about the build and deploy process versus the in-page, the end user process. So in terms of the scope for these requirements, we're not talking about anything that's on the server side. We're actually talking about when this is rendering in the client browser. So your tamper detection doesn't apply to, like, it's not file integrity monitoring. It's tamper detection in the session of the browser. So it's within the actual session where the consumer is actually using the browser. Depending on what your compliance looks like if you're doing a ROC, for example, or you're a service provider, you would have requirements pertaining to tamper detection. So like an SAQ A-EP, for example, if you build a custom application that captures and stores cardholder information, or an SAQ-D or a ROC. But if you're using an SAQ, if you're doing an SAQ-A, it's only in the context of the session where that user is navigating on your page. That's where the tamper detection comes in, and it's manipulations to the scripts as they're being loaded in the browser, and manipulations to the HTTP headers as well. So things like content security policy. Good question, really good question. We got a couple of minutes left. Any other questions? I think doesn't look like we have any. I don't think we turned on the chat, so we don't have any in the Q&A. Any other questions that we can answer for you? I can hear the wheels turning through the Zoom session.
They call it a door handle question. It's like when you go to the doctor and doctor asks you all this stuff, and then the last second, as they're about to open the door handle to go out, somebody goes, "Oh, I really have this thing." How much does it cost for source defense? That's something I'm happy to get into, but we need to discuss your particulars. If you hit sourcedefense.com, we've got a contact us form right there, or you can actually sourcedefense.com/free PCI. We'll kind of let you see a dashboard of your own stuff and get the conversation started. So love that.
You can also reach out to us on the MNP team. So reach out to your assessor, reach out to your QSA or your consultant. We can connect you with the source defense guys. What's really great with this partnership is we have sort of that intimate view of your environment. We understand your environment, so we can kind of paint the picture for you from the PCI perspective, or paint the picture for the source defense guys. Yeah, just reach out to us if you have questions about source defense or about these requirements, and we can connect you as well with the source defense guys too. So, okay, if you have any other questions or anything, please reach out to us. We're happy to help you out. We appreciate your time. Thanks for joining us. And Matt, thanks for sharing the product demo with us. Our source defense looks pretty cool.
Thank you very much. It's great to have the opportunity, and I hope we can be of further service.
Okay. Have a great day. Take care.